Hello and welcome to Gus Codes. I am Gus, and in this session of xganso I'll take the first real step into the world of ECS by deploying a new renderer system that brings our units visually onto the battlefield. The goal today is to start rendering using ECS instead of the old custom logic. That means cleaning up the existing unit rendering code, building a new system that draws entities based on their position and sprite data, and hooking everything into the main game loop. We will implement three core components: grid position, sprite and render layer. Define how the render system processes them, and then connect it all to the ECS world to display units on screen. It's a foundational change that sets the stage for a full transition to ECS and enables future systems like movement, combat and AI. Let's start coding. In the current setting of xganso, we have the units being represented as the circles with an uppercase letter, and currently each cell holds the unit information. So we are gonna move away from this more object-oriented approach towards a more data-oriented approach with ECS. The first step is that we have to clean up and remove the current implementation, so then once we implement our ECS Renderer system, we can hook up with our game loop and there won't be two systems. But it's important to notice that currently we are not gonna make a full transition in the rendering system, so it's only gonna be the units that are gonna be rendered via the ECS. So this is gonna be a gradual process. So first we're gonna clean up our current unit system for rendering. Okay, so there are some things that are important to notice. So the unit is being used for the UI as well, to show which unit is on the cell, and it's also apparently used for the path finding. So I'm not gonna remove completely this data, I'm just gonna make it that it's not gonna be rendered. It is not so ideal to have multiple representations of the same system, but at the time it's something that we are accepting and we are aware of that. Okay, so as we can see, currently it doesn't show anything anymore, but when we find the correct one, it still shows this information. I'm gonna keep this as it is, and maybe in the future we can also convert this. So I would say for the cleanup or for setting up for our new system, we are done. We don't want to break too many things. And then now let's focus on implementing the render system in ECS and connecting it with our system. I am going to make a different folder because I want this to be the pure system and this to be all the implementation of the systems. We will have three components. The first one is the grid position that will give us the position that we should render. The second one is the sprite, which images should be rendered, and the last one is the render layer, in which depth it should be, so we can have like multiple layers of rendering. The idea is that the component is only data and it should be very concise, so it should do one thing and one thing only, also with the system. We set up the grid position, we need to know which cell is, which is represented by the Q and R. The render layer is the Z, is the depth that we usually use, and the sprite is the image. We're gonna use the Pygame surface for that. Okay, and so now let's move on to the system. Right now we are just going to use render layer as one, we are not having different layers. And I think we might have some issues with all this get entity component because we're passing a class and not a type. We might have to do some refactoring on that. This is the system, so we receive the ECS so we can get the entities eligible that we want. We need the screen so we know where to print, and we need the camera to convert from word to screen. We get all the entities that have a grid position and a sprite. We get the grid position and the sprite from the entities. We convert the grid position to screen position, and then we print on it. So now we need to configure our ECS and hook up with our existing system. Okay, currently we're gonna have two systems working in parallel. One is object-oriented and one is data-oriented, and it's not gonna be the prettiest solution at the moment, but I'm just gonna make something that works, and then when we start transitioning completely to the ECS renderer and get rid of all the object-oriented stuff, then we can improve a little bit better. But now we might have some weird stuff happening around. Maybe something we should try to print only this image. So let's make a little example. Oh yes, of course, we haven't added our system. So I think we need to add here. Okay, nice, so we already print something. Currently is of course in the starting position here. We're gonna fix that. And also one thing that we have to do is increase the range, because our images are 48 pixels, so our cells are gonna be 64 now. And also the camera should have bigger zoom option, so should be maybe this. Let's see how it goes. Yes, okay, so we need to convert first from hex to the word point and then word point to camera. So we need a little bit more than we have at the moment. We also need the layout in our rendering system. Of course, in the future we're gonna adjust better how these dependencies are ejected, but for the time being we just wanna make it work. Okay, it seems better, I guess. Now the question is how we make it center and how we adjust according to the zoom level. Okay, when we zoom in we see that it's not masked. It's also not cropping here, but that's fine I guess. And now the thing is that it's put in the center as the left. How can we fix that? Also, I think the cell are too big, so maybe let's adjust that half the size. Maybe it's considering as half the size. I don't know. Let's find out. Yeah, that looks much better. Here's the center, so I have to get the top left. Ah, they should be here. Okay, so I need to reduce it. Okay, perfect. They are exactly where they should be. Now let's just link our position to the correct position. So after the setup we can do that. So let's just get all of these components. Okay, let's skip this two for the time being then. Okay, cool. The knight, the mage, and the archer. And it's correctly. And of course the resolution we still have to work, and still have to work on cropping. So maybe we can have the map view as a parameter for that. But overall I'm already happy with the result. It seems to be working as expected. I just don't know why the other two cannot be. Oh, of course, I didn't put them here. So now it should be okay. Okay, now we have the whole gang here. The bard, the archer, the rogue, the knight, and the mage. Cool, that's it. Let's see what we did of changes here. First, we added all the images. So let's add them. Ah yes, one thing that may be important before, we had to do some change. Oh no, but it worked quite well. The component type thing. And I think the test should be working. Everything is working, but yeah, so nothing broken there. That's great as well. This test sprite, let's remove it, we don't need it. Let's remove this refactor too, because it's old data that's only bothering me. And this one as well. The backup, let's leave it because it's the map, in case we make a blunder. Okay, let's see here. So in the main battle, we hook up the ECS. We created the ECS with the word. We created an entity for each of our units. We added the components of the sprite, and then later the grid position. We removed the goblin and the orc at the moment because they don't have anything, but also if we kept them it would be okay because they are just not gonna be shown, but it's not gonna break anything. Exactly, so let's just keep them. Okay, so and then we added the ECS execute as well here to draw. For the battle view UI, we changed the hex layout. We use 32 now. I think it's half the size of the pixel actually, because it might go upwards and downwards. Our 48 pixel image fits very nicely in this one, so we're gonna use 32 for the time being. So the grid position is one of our new components. It just have the Q and R. It's a question if we want to have integer or if we want to have hex coordinate. I want to keep this more independent as possible, but also I think the hex coordinate is quite stable. So we have to see in the future, because we are doing a lot of conversions of data in our processing. The render layer we added, but we are not using at the moment, so it's more for a future purpose. And this sprite of course is reliant on the Pygame surface, so we just inject the data there. And I don't know, maybe if because we are using the Pygame, so I think it makes sense to have this kind of dependency. We are not gonna change our game engine, so that's fine. The rendering system, okay, we have a lot of dependencies that are injected, so the screen, the layout and the camera, and we get all the entities that have grid position and sprite, so we can display them. And then we have to do all this calculation, getting the word position, getting the screen position, and then finally doing the scale by. Usually in the ECS the system should do one thing and one thing very well, so it's kind of like a microservice if you consider that. So in the future we might break this render system into different systems. So one is gonna be the calculate screen position, so it will take this grid position and transform into screen position, so we won't need the layout and the camera here more as dependency. Well, now that I'm seeing, maybe one should be the image scaler, so it will set up which should be the final image, and then the renderer will only take the image and put on the screen. So all this extra calculation would be done by other systems, but still something in the future. At the time being, more prototype idea, more exploring and seeing how it works. It's currently fine. The hex camera, we added the zoom because now we have a bigger cell, so better to have more zoom so we can see more of the map at once. The hex map view, we removed the draw unit part, and maybe we can also remove this draw unit because we are not gonna see it or depend on it anymore. We're not gonna go back to it, so let's just remove this draw unit. I don't think it's used anywhere exactly. And the hex geometry, we added this hex to top left, so we remove the squared root of 2 divided by this, so then it can centralize our symbol. So now we can commit this session 7, implement ECS Renderer System, and yeah, we commit and we push and everything is great. And yes, so now everything is working and we're very happy with the results today. To summarize, today we started transitioning towards our ECS architecture, starting with the renderer system. We cleared out the old system, built a new ECS rendering, and saw our units come to life on the battlefield. It was a big step forward. The implementation of the renderer system was a big success and it went really smooth. It shows a lot of potential for our future with ECS. Since it was the first system, we had to create all the components, and it seems that there will be a lot of components in the future that we will have to track. There were minor obstacles in the session with the screen point calculation and the zoom to scale in the image. In particular, I used a reduced image version with 48 pixels, which is fine when zoomed out but shows bad graphics when zoomed in. We probably need to load different sizes and adjust them according to the zoom level. In the next session, we'll continue developing our ECS architecture. Transitioning the movement system won't be straightforward. It requires careful planning and design to leverage the existing pathfinding module. But once complete, our units will be ready to embark on their journey across the battlefield. Thank you for your time and see you in the next session.